Hi guys, today we're going to look at differentiating ln, or the natural log of x. So log e and log base e is called the natural log. It is opposite to e to the x, which is why it's got an e in it. And what we need to realise is that when we differentiate natural log, we get a different function altogether. So when we were differentiating, we didn't have anything that differentiated to 1 over x, because 1 over x becomes x to the negative 1. So when we differentiate that, we get negative 1 x to the negative 2. But there's nothing that when we take 1 away from the power, we get negative 1. So it's interesting that this is actually what ln of x does. So in the formula sheet, it says if you've got y equals ln of x, and we write absolute values around it, guys, because there's no natural logs of negative numbers. We can only have positive x's. So we make sure that we have absolute value signs around it. Then the dy by dx will equal 1 over x. All right? So when we use this, we are taking whatever is following the ln. So we should try and keep these things in brackets. Let's have a look. So if we've got y equals ln of x, 3x, like that, then when we differentiate it, we get 1 over 3x, but it's the chain rule too, so we have to differentiate, multiply by whatever 3x differentiates to. So the answer is 1 over x. Now, interestingly enough, it doesn't matter what number is in there, the answer is always going to be 1 over x. So it becomes more interesting when it's a function, a different sort of function in there. So if we've got y equals ln of 3x squared plus 7x, then when we differentiate this, our first job is just to write 1 over that, 3x squared plus 7x. That differentiates the ln. Now we have to worry about what's inside. So we multiply by, take the power, multiply by it, 6x plus 7. All right? Now one thing that comes into this is the log rules, because log rules actually can help us a lot. We could split this up using log rules. So ln of this will equal ln of this. Ln of this could be ln of 3 plus ln of x, and ln of 3 is a number, which is why it disappears, and ln of x differentiates to 1 over x. All right, so if we used log rules, we could write that as ln of 3 plus ln of x. So when we differentiate, we get 0 plus 1 over x. Same thing. Sometimes it's useful to use your log rules to split things up. So they might ask you to do something like this. Y equals ln of 3x squared times 4x cubed, right? We don't need to use the product rule for this one. We can actually split it up into ln of 3x squared plus ln of 4x cubed. So when we differentiate it, we get 1 over 3x squared. And actually, the top line is what it differentiates to, 6x plus, bottom line, 4x cubed, differentiate, 12x squared. And we can prettify it too. All right, so that's going to be the answer. Okay, just going to check. So this one is quite an interesting one because it gives us an interesting answer. If we've got y equals ln of 4x to the power of 3 plus 5x I don't really need all those brackets actually. Get rid of those ones. squared, all right, then if we do this one, what we're going to get is dy by dx equals the bottom line, 4x cubed plus 5x squared. Actually, I'm going to put 2 in the front here because I need to explain that. There's a number in front of 2, just like when we did each of the x's. That number there is just a 2. 2 of these will give us 2 of these. All right, so just drop it down, make sure it's in your answer. Now we have to differentiate this, which is 2 of the thing in the brackets, decrease the power by 1, multiplied by whatever's in the brackets. Okay, that's a pretty horrific looking thing. What is actually easier is if we take this and use our log rules, we get y equals, take the power and put it in front, 2 times 2. 2 times 2 is 4, so I'm going to write 4 ln of this. Now if we differentiate, we get 4 of this on the bottom and whatever this differentiates to on the top. Now, apart from being written terribly, 4x to the power of 3. That's much nicer than this, but they are the same thing. There's your 2 times 2 is 4. There's your 12x squared plus 5. We've got 2 of these, which should have been in brackets down here, and 1 on the top, which cancel out to give 1 on the bottom. So they are actually exactly the same thing, but by using the log rule, we've made it easier to differentiate. So we should be looking for this as an option. Okay, a bit of work to do today. Try not to do every single one. Just do enough to do 50 minutes-ish of work, okay? Thanks, guys.